Hello, my friends from everywhere in the world. Thank you very much for coming for another DevNation Master Course. And today is part two of the Kubernetes Master Course. I'm your CodeCaster today. My name is Edson Yanaga. And first, let me greet you, all of you from everywhere in the world. So I'm going to move here to my chat. I can see a lot of people are here already saying hi on the chat. Yes, please post from where you're watching this streaming today, so I can say hi to people from Milton Keynes, UK, Chennai, India, Ellicott City, Maryland, St. Louis, Missouri, Antwerp, Belgium, London, UK, Montevideo, Uruguay, Cortria, well, sorry, I can't pronounce that, but it's from Belgium. Kerala, India, Phoenix, Arizona, Vancouver, British Columbia, Lodz, Poland, Venezuela, Johannesburg, South Africa, Singapore, North Carolina. Yes, I'm streaming live from North Carolina. We might be even very close. Yeah. Chile, UK, Denmark, Huntersville, North Carolina too. Mexico, Mexico City, Milan, Boise, Indiana, yes, or Idaho, I suppose. Yeah, I'm not familiar with the US states yet. Valencia, Spain, Yekaterinburg, Russia, Brazil. Oh, thank you very much for coming from Brazil. New Jersey, Hong Kong, Makati, Philippines, Kazakhstan, Brasov, Romania, France, Idaho. Yes, I knew I was missing somewhere. Idaho, Ennisland from Scotland, Salisbury, Maryland. So yes, we have a lot of people connected to here, and of course, I'm very happy because I'm going to talk about a very nice subject today, which is Kubernetes. Okay. Algeria, hello, are you from Algeria? Well, yes, we have people from many different continents. I think we covered almost all of them. Do we have somebody from Australia or New Zealand? Yeah, might be covering that piece of the world too, but maybe it's too early or too late for them. So yes, I can understand why we wouldn't join this particular stream because we have the same content in an Asian-friendly time zone too, if you want to check in the schedule. By the way, if we're talking about schedule, oh, hello to Ukraine too. Dnipro, Ukraine. I don't know if that's close to Kiev or not, but yeah. The world is a big thing. You can't possibly know where every piece or every city is in the world, so let's move on. Let me show you my slides here. And yes, today's Kubernetes Master Course Part 2 or Elementary, depends on how you look on that. And of course, since we're talking about schedule, I just mentioned that we have these master courses in different time zones in Asia too. And today we had the same course presented in an Asian time zone. We had in French, we had in Brazilian Portuguese just 2 hours ago. Right now, I'm presenting at noon in US English in US East Coast. And a few hours from now, 2 hours from now, we're going to have the same content in Spanish, so you can pick your favorite language and favorite time zone. And don't forget that next week, July 13th and 15th, we're going to have the Kafka Master Course and the Istio Master Course. I think Kafka, if everybody wants to use Kafka in their applications today, so we're going to cover that on next Monday. And if you're really interested in Kubernetes and you want to level up your skills, you can check the Istio Master Course, which, by the way, Istio is a more advanced course. So if you're starting with Kubernetes, well, maybe you need to become a bit more proficient about Kubernetes. But if you want to know what is possible to do with Istio with a service mesh on top of your Kubernetes cluster, then that course is for you. You should be joining on next Wednesday, where I'll be presenting in English too in the same time slots. And on the week of July 20th, we're going to have the Kubernetes operations master course, operations 1 and 2. So right now we're trying to focus on developers, but if you want to go to the the operations part, you want to be a system administrator working with Kubernetes, then the week of July 20th is for you. And finally, in the last week of the month, we're going to cover this beautiful summer that unfortunately most of ourselves, including myself, are inside. We're going to have the Tecton Master course, which teaches how to create Kubernetes native deployment pipelines that don't consume resources. If you're still using Jenkins in your deployment pipelines and Jenkins is consuming all of the memory in your cluster, maybe you should try to see Tecton. Okay, so that's the schedule for at least this month. And you can register for all of these courses. I'm going to copy paste the URL here. Yes, we have a question here from Stu Whitby. What's the operations course? System administrators? Yes, exactly. That's for system administrators. So the operations, if you want to be a sysadmin, that course is for you, and if you want to deal with the Kubernetes operations part, right? So we're talking about using Kubernetes to deploy our applications. And let me do a quick demo for you. Okay, so I'm going to switch to my terminal here, and you can see that I already have some scripts ready here. So we're going to switch here. I have a Spring Boot application running here on my machine, and let me check. I think I can split my screen here vertically, and let's try to watch the pods. Watch kubectl. Oops. kubectl get pods. Okay, so I have one pod running. It's a Spring Boot application running, and we're going to update the deployment that I have right now. So if I do this, I can, for example, try to change the image. And one thing that I didn't show on last Monday, but I can show you right now, for example, I have this particular deployment working, get deploy. You can see that I have the my boot deployment working. One way for me to update the image that is working, for example, is for me to edit the deploy. Okay, and you can have like many different editors. You can use your favorite editor to be using. So, and it's basically using the editor environment variable, but we can specify a different environment variable. Like if I say cube editor, cube equals to, well, it could be, for example, code. And if I specify that I want to edit my Kubernetes YAML files using Visual Studio Code, and which I'm using the YAML plugin, by the way. And if I say kubectl edit deploy my boot. Okay. Oh, it didn't work because I forgot one particular piece. It's not -r, it's -w. Okay. So if I do the same again, edit my boot and switch here to my Visual Studio Code, you can see that the kubectl command line opened that file in my editor. Okay, that needs to be -w on Visual Studio Code because, well, it needs to wait for the command to complete. So if I just do this, and you can see that if I go to the YAML file, you can see here that the image is specified on this line. So if I just edit this, let's update that to version 2, and I'm going to save this file. And I'm going to switch here automatically because I want to check this screen. I'm going to save this file and close this. You're going to see that, yes, you can see here on the right top side, yeah, it's updating, and you can see a lot of curve fails in the top left side of your screen. So, and why is that? Well, because it's a Java application, it's traditional Java, it's a Spring Boot application, and takes a lot of time to start up. And while you're updating the images, you're going to see a lot of errors because, well, my Java process is already running, but of course it's not ready to reply to my request. So that's what's happening right now. I updated the image. You can see here that this version is running, the other one is terminating, but I had a lot of error messages here on the top left of my screen. Okay, so, and how can we prevent that? Well, we are going to learn today how to prevent these errors, but I want to show you another update. So you can see here that I edited my deployment. That's one way for me to update the images, the image that is running right on now on this particular version. But if I want to give a new version to my particular application, I can also use this command, kubectl set image. Can say deploy equals to my boot, and here I'm going to use a selector. By the way, it's going to be my boot. The new image is going to be this one, key.io /rh developers / let's switch to Quarkus, for example, Quarkus-demo v1. Okay, so I use this, and you can see that, oops, Quarkus is so fast that you didn't have any error messages. So you can see no errors from curl and being super fast. You can see the Quarkus is already running here, and the old version is still terminating, right? And why does it happen? Well, Quarkus is Java, but it's not the old Java that you're used to, because Quarkus, as you can see here in the hello message, Quarkus is supersonic, subatomic Java. It's super fast and super small. It consumes like a very low amount of memory and starts super fast, so you can't even see the errors. So basically, this demo is how can you it's basically to show you some of the issues that we have when trying to perform updates of your applications inside your Kubernetes cluster. So you have to take care of that because, well, maybe if your application is not ready, Kubernetes shouldn't be sending production requests to that. But I've shown you also that Quarkus is so fast that these errors doesn't happen. Okay, and let me check here the chat. Honghai Leon saying the operations 1 and 2 are not open for registration yet. Not yet, but you can expect next week probably the master courses for the other week will be available for registration. Okay, we need the marketing team to update that, and sometimes it take they wait, or else it's going to be a big list on the screen. So they wait for until like there will like 2 weeks apart from the course to be able to update the registration page. Okay, and Tony is also saying the tutorial from the other day requires VirtualBox to do. Do you have any other workaround, maybe VM Workstation or Overt? Yeah, it should be working on other virtualization options if you're using Minikube. We're just using VirtualBox in the tutorial because, well, we don't have enough bandwidth to be testing all of the possible virtualization solutions. So if you check the Minikube documentation, probably you can use like, for example, if I'm using a Mac, I can use Xhive. So you have other options. You just change the commands. Everything else should be the same. Just the command that you use to start Minikube should be different. Okay. So we're just using VirtualBox because it's available in all platforms and because we only have enough time to test one of the options, right? So that's the only reason, but should work in other options too. And Sean is asking, will these courses be available after the air? Yes. If you have the link, if you're watching this live, you already have the YouTube link. We're not going to delete the video. You can watch it later. Or if you want to rewatch it, another version, for example, the Kubernetes Master Course, we're presenting that every single month. So this is the first week of July, and we're watching this Kubernetes Master Course. And probably in the first week of August, we're going to repeat the Kubernetes. And remember, because it's live, it's always different. It's always fun. I'm always presenting something different way, based on the feedback that you give me to me. So we're just trying to change the things. Okay. Yes, and Tommy is replying. Yes, sometimes it takes some time to be available. Well, it happens because of YouTube, not because of something that we do. But yes, as Tommy says, you can rewatch it later. Okay, and back here to my terminal. You see that I was able to do that, and on last Monday, somebody asked me about, oh, I didn't understand the difference between deployment and replication controller. Well, the nice thing that I'm using in deployment is that I can see the history. And how can I see the history of changes in my deployment? I can use this command. So I can say kubectl rollout history. When you do that, oops, history deploy / my boot. I need to specify the resource, okay? And you can see here that this particular deployment has 3 different revisions. And why is that? Because I have the first version that was in Spring Boot Aloha, saying Aloha. Then I changed that to a version using Spring Boot that is saying Bonjour. And the third revision is showing me the version that is running Quarkus. Okay, so I changed the images between those deployments. And you might be saying, well, why is the change cause empty? Because if you want to show some of the strings, you have to annotate your deployments, which I won't be able to show today, but you just need to edit your YAML file or manually edit the annotation here. If you add the annotation to the deployment, it will show you here the change cause, okay? So if Kubernetes with the deployment knows the history of what happened to this particular resource, I can, for example, undo the change. And that's what I'm going to do right now. For example, I can say kubectl rollout undo deploy, and I'm rolling back. You can see that I'm rolling back. It's changing the image. You can see some errors here on the top left side of the side of your screen because I'm switching back to Spring Boot, and now the version saying Bonjour, it's working. So yes, I'm working version 2, and if I ask you to see the history, if I ask a rollout history again, you can see that now I have revision 1, 3, and 4. Usually the command by default only shows me 3 revisions, and I don't know why it's run 3 and 4, but well, you have like 4 is the rollback version. But if you want to switch back to the first version, for example, I can rollout history, rollout undo, deploy my boot, and I ask, for example, to revision equals to 1, you should be, it's going to take some time because it's traditional Java and it's going to have some errors. You can see here them again, and it's going to show me Aloha again. Okay, let's wait for that. Yes, you can see in Aloha, and that's why you can see the history. When using deployments with replication controllers or replica sets, you don't have this feature. So if you want to know the history, if you want to be able to roll back to previous versions of your deployments, you need to use a deployment, okay? And here, Chris is asking, can Kubernetes hold off on terminating one deployment till then one passes a custom health check? Yes, and that's what we're going to learn today, okay? So I just shown you if you don't do anything, that's the default behavior of your Kubernetes cluster, but we can improve on that so you don't see the errors when we're trying to update anything. Cool. So Manuel is saying, yes, it can. Yes, and that's what we're going to learn today. Okay, and what else? Oh, I forgot. I have to show you the slides for today, which is not much, by the way, because it's almost live demos. We're going to post it here in the chat, CubeMaster 2. And remember, everything that I'm showing you today is available here on the Cube tutorial. Okay. Yeah, Manuel is saying it depends on the rollout type. Yes, depends. We're going to perform rolling upgrades, and I'm going, which is the default, and I'm going to show that for you just in a couple of minutes. Okay. So you have the content available on the chat, and if I go back here to my browser, you can see that that's the tutorial that we used last Monday, and we have the requirements, we have the beginner part, and today we're going to see the elementary part. And the first part today is building image, but first a very quick recap. So I'm just going to switch back to the slides. And, oh, a slide about myself. Well, I shouldn't be repeating that. And actually, in one of the streams, somebody suggested that, well, maybe I should be recording this presentation because it's always the same. So if you're watching me frequently, you might get bored about that. But yes, my Twitter is Yanaga. You should follow me if you, you should follow me if you don't yet, because I talk a lot about Java DevOps microservices, cloud computing, Kubernetes, hybrid clouds, and all sorts of stuff. And I'm also a Java champion on Microsoft VP and a Brazilian Japanese. All of my grandparents are Japanese, but I was born in Brazil, and I didn't have time to show that. But you can see here, I'm covering that. I'm also no, here. I'm also at the DevConf Rockstar. The DevConf is the largest software development conference in Latin America. Every year they have like 25,000 people, and 3 years ago, they granted me this DevConf Rockstar Award because while I was in Brazil, I was the person that presented the most amount of talks ever. And I've only been doing like public speaking since 2012. So yeah, it was quite an accomplishment. I'm very happy about that. So let's move forward. So the agenda for today is building image, resource limits, rolling updates, liveness readiness probes, and environment and config maps. And if you're wondering, oh, I would wish to learn how to do like access control, authentication, authorization, or persistent volumes because I want to have like some stateful image that needs to write to the disk. Well, we are preparing the next step of these master courses, which is Kubernetes Master Course Part 3. And just wait because probably, well, in the fall, we're creating new master courses and we're going to add Part 3 to the portfolio. So just stay tuned. Just follow us on Twitter. If you already subscribe to the newsletter, you're seeing what we're doing. So yes, we're preparing new content for you. Okay, and we're always updating because based on feedback, we know what we have to improve, what we could change. So thank you very much for submitting your feedback for us. And I have a question here. Daniel is asking about the hybrid cloud from last Monday course. Would you be able to launch the demo with the always free version of the AWS, Azure, and GCP services since the demo is small? Good question. I can't tell specifically about pricing because my account is super old. I'm not eligible for the free tier anymore. But I think not. Okay, but it's just an opinion. But even if you're using like plain Kubernetes, you would need to spin, I think, at least 2 machines, and I don't know if they would be covered by the free tier. So I really don't know the answer. If you're trying to deploy OpenShift, I can totally say to you that no, it's going to cost you something. so it can't be like free. But what you could do, well, you can try to spin like multiple mini cubes, for example, in your machine if you have enough memory for that. And you would be able to use the hybrid cloud, because hybrid cloud means that you can have like even like multiple different private data centers. You can have a hybrid cloud, multiple different public ones. So you might save you some cost if you want to run the hybrid clouds. But if you really want to try that out, I can even try to deploy a cluster for you. Yeah, if you want to show somebody something that I can always have some cluster running somewhere for something. So I can leave it up and I can give you the credentials for you to deploy, or I can deploy that for you. Just don't do some Bitcoin mining, because yeah, it would be nice. Okay. So move forward. Quick recap. We learned well the challenge of why we should be using Kubernetes, and we learned about some terms: the pod, replica set, serves, persistent volumes, and labels. And I hope I was able to explain properly to you what's the difference between replica sets and deployments. And now let's dig into the part of building images. How do you build images to run on Kubernetes? And the interesting part is that Kubernetes is a platform for you to run images. So Kubernetes by default, it doesn't help you to build your images to be running, but most Kubernetes distributions, for example, which is the case with OpenShift, provides you with like nice deployment pipelines. And actually, if you're running OpenShift, you'll be running Tecton pipelines, which allows you to build from your source code. It gets your GitHub repo, your source code, and runs the pipeline, builds the image, and you can ask OpenShift, for example, to run your image. But if you don't, first you need to find a way to publish your image, and probably you can publish to a private registry. You can use Docker Hub, you can use key.io, gcr.io, the Google or Access redhat.com/containers. These are some of the public registers that you can use to publish your image or consume your image. Another option, second step actually, you need to craft your Docker file. And remember, we're just trying to stick to the basics. We know that you can use plugins, for example, Jib, and others if you use Jcube. And there are a lot of different plugins that you can use to create your image, but you're sticking to the basics. So yes, you need a Docker file, you need to do a Docker build, you need to craft a YAML file for the deployment, a YAML file for the service, and you have to apply those on Kubernetes, and you have to find an option to expose these things to the internet. You can use a Kubernetes ingress, you can try to access the IP of the service directly, or if you're using OpenShift, you can use an OpenShift root. So these are some of the options that you can use to run your application. Also, if you're using Java, be aware that we have a lot of stuff that doesn't work properly in older versions of Java. For example, if you're using an ancient version of Java 8 something, you might have issues with Docker, because most applications in the past, they were designed to run like in machines or virtual machines, and they would assume they would have the entire memory available for them. When you're running in containers, you have constrained environments, so you can't see the whole memory of the machine and think that everything is available for you. You have to look at how much memory your container has available using the cgroups restrictions. Okay, so this is so you can check later. We have some links here on the slides, and let's try to build something. So I'm going to switch back here to the tutorial. So let's follow the instructions right now, so you can follow. So I'm going to go back here to my terminal. All right, and let's see. I'm going to close these tabs so you can see in a bigger screen. So what we can do right now, so I'm going to first, let's try to build a Java application. So I'm going to switch back here to this folder. I'm going to execute an mvn clean package. Okay, and it's building. Oh, it was pretty fast, like 3 seconds. It should be running. Let's try. Target boot demo 100 jar. Yeah, it's gonna take some time. Yes, Java sometimes can be very slow. So yes, it's up, and it's going to take some more time to initialize. So if I go back here to my browser and go localhost 8080, yes, Jumbo phone Spring Boot on unknown. It's saying unknown because I'm not running inside the pods, so it's just localhost. Okay, so yes, it's running. So how do I build a particular container image from this application? So if you look here in this particular project, which I'm going to show here in the terminal, you can see that I have a Docker file. So let's try to that Docker file. So you can see here, I have a Docker file, I have the from image, I have the environment variable, the work, copy, expose, and the command java -jar, the Java options. Okay? So that's how it works, and it should be good. So how do we build this image since I already have a Docker file created? And by the way, everything, all of this, if you want to check the Docker files, we have like multiple different options that we created here with Java 11 for OpenShift, for with memory constraints, without memory constraints. If you want to build an image, you can do this, Docker build, and I'm going to pass a tag. If you don't create a tag, it's going to be some random number, random name. I'm going to say key.io, which is one of the public registries that you can use. You're going to have to type the name of your repository. In my case, if I'm publishing my repo, it's going to be, for example, Yanaga, which is the name of my organization or my user. And my repo is going to be the name of my repository that is available on key.io. Okay, and I can also pass a tag v1, which is always good practice. If you don't specify the tag, it's always going to be latest, which is a bad practice for running anything. So you should always have like a proper name, v1. And I pass the current folder, because it's where my Docker file is, and it's from where I want my commands to be executed. Okay, so all the paths are relative to the current folder. So if I just do this, it's going to build, and it was like pretty fast, wasn't it? So how do I run this image to know that it was working properly? What I can do, I just need to change here to Yanaga because that's the one. So what a Docker run is going to remove the image after it's finished. It's going to be interactive, which means it's going to block here. Mapping the port, the name is my app, and this is the image that I want to run. Let's try. Running. Oops. Yanaga my app. Oh, it's my repo. Oh, actually, we have a typo in the tutorial because I just copy pasted that. Let me fix that. And if I don't remember, please somebody ping me on Twitter saying, oh, fix that tutorial because the name of the image is wrong. So it's running inside the container. If I go back here to my browser and go to localhost 8080, yes, it should be working again. And now you can see the hash of the container that is running. Okay, cool, isn't it? So yes, I created a container. It's successful. It's working. And let's go back here to my terminal and stop. Oops, I stopped at that. Let's run again because I forgot to show you something. So right now it's working. Well, yes, Java sometimes takes forever to start. But if I open another tab here, 8080 sees resources. Yes, you can see that how much memory do I have available? Well, I have available 2 gigabytes of memory, and I have 8 cores available on my machine because that's the configuration that I use it in my Docker desktop virtual machine. Okay, so this container is seeing the entire memory available for running, which is a bad thing because this memory should be shared among multiple different containers, right? So how do we fix that? Well, we can try to fix what are some of the things that we need to do here. We need to fix the memory constraint. So I can't allow a container to run unconstrained in a particular environment because, you know, they need to be good citizens. There are other applications that want to run in the same host. And even if you have like 128 gigabytes of memory, if you have an application that has a memory leak, for example, a Java process that is going to consume the entire heap, the entire memory of your host, well, it's a bad practice. So how do you limit the resources that each one of your containers can run? So if you're running Docker, for example, I can use this one. And it's going to be Yanaga, my repo. And so here I can say we're going to share, we're going to limit this process in particular will be only be able to, this container is going to be capable of consuming only 400 megabytes of memory and only 1 CPU. Okay, so if I run this container again, and let's wait for this Java application to run. Yeah, it's slow because, well, I constrained the memory, so it's taking longer to be able to boot. So if I run the same endpoint, you can see here, even though I constrained the memory and the CPU to like 400 megabytes and one CPU, when I ask this endpoint how much resources do I have available, it's showing everything for me, okay? And the problem is that I'm using an old Java version on this container and I'm not setting the correct JVM parameters. And the same applies to many other different languages. So how do I fix this? I'm going to fix this by creating another image with another Docker file. So I'm going to build here. It was super fast. What was this Docker file? You can see here that I'm using an updated Java version, and I'm using the cgroup memory limit for heap flag to be able to limit the amount of memory that this particular process is going to consume. Okay, so if I run the same thing now, let's run it again. Okay, has some debug statement, additional debug statements, and yes, now it's working. So if I just go back here and curl the same endpoint, now it should be showing me, yes, the constrained resources. So it's only allowed to consume, now it's consuming only 112 megabytes of memory. So you see it's consuming much less memory because it's seeing that the total limit that you can consume is 400 megabytes. And it's seeing the total amount of cores, but it's much lower because it's only using one CPU. Okay, cool, isn't it? What else can we do? Well, let's try to crash it. I just have a for loop that is trying to consume all of the memory available in the container, and it didn't crash, right? Let's assume it's still working. Let's go localhost 8080. Yes, it's still working because the JVM didn't try to explode the amount of memory available. It's constrained, and I forgot to make the image crash. Sorry about that, but let's see if I can do that again, because I have the other image here, Docker run. This is the old version without the memory constraints. Okay. Everything is super slow when it's trying to stream, right? And come on, Spring Boot. Yes, oh god, almost 15 seconds. Takes forever. So if I show here now the sys resources, yes, it's the Java process seems to think that it has the entire memory available. So if I ask consume, it's super slow. Yes, as expected. And come on, come on. Super interesting, right? While it's trying to consume the memory, let's see here. The chat. You can see Peter, congrats on the Rockstar Award. That's fantastic. Thank you very much. I really appreciate that Rockstar Award. It means a lot to me. And basically, I like to think that when I'm trying to speak at the conferences or publishing tutorials or making anything else, we're trying to help people to become even better developers. I think developers, just such as us ourselves, we have a very important role in this like modern world. Everything is enabled through software, and the better software we deliver, the better lives we can help to create. So yes, and the way I think about my job is that I'm trying to help developers worldwide to become even more awesome developers. And I think that's why I'm so happy to be here with you today, because I hope that with something that I'm teaching you today, you'll be able to become even more awesome. And you can see it took forever, it didn't consume everything, okay? And what's happening here? It's still consuming. Let's try to run it again. Did it crash? Let's see, current localhost. Yes, it crashed. So the purpose of that was try to crash this container. I was expecting like an error here, but it didn't show up, okay? So yes, it's crashed. So if you don't limit, and if your Java, for example, application or any other environment is not aware of the container constraints, you will receive a crash if you don't deal with that correctly, okay? And the last part here of building images, if you want to run this image on Kubernetes, you should be able to do a Docker. For example, you could log into your container register, docker login key.io. It's going to ask you for the credentials. I logged it before, but that's why it stored my credentials here. And if you want to push it, you should be able to do that using a Docker push key.io, like my repo or Yanaga slash my repo v1. Okay, but I won't do that because I won't be using the image and I want to mess with my public registry that is over there. Okay, but basically that's the process. So once you do the push, you will be able to see your public image over there. Oh, by the way, the images that we're using this tutorial today, if you go back to your browser, you see that we have a lot of images available on this particular repo, RH developers. And let me see my boot. So here's the my boot image that I used in the first demo. We're going to reuse this one later. I also have the Quarkus demo image here. So we have a lot of images that are used through our different master courses and other demos that we have. So you can check. You can create your own free account here on key.io, right? Cool. Okay, let's move forward because we don't have much time today because we have a lot of content. Moving back here, I want to show you resources and limits. So everything that we did, we built the containers, we set some constraints running on top of Docker, but how do we set these constraints using Kubernetes? Okay, and let me check the chat here. Peter is saying just installed bat 2. Yes, bat is a very nice replacement for cat. It works, it behaves as cat if you pipe the things, but if not, well, bat is a very useful thing for you to show the Docker. Actually, you can even put an alias. I've put an alias to cat to be bat, so you can see here that even if I perform cat, I would be able to see this syntax highlighted thing. And it's even nicer if you try to cat, like for example, Java files or YAML files. It's much easier for you to read and understand the files, okay? And Gabriel is asking, is it possible to handle interactive scripts that expect password inputs in Docker initialization scripts to install third-party dependencies? Not that I'm aware. When you're trying to create Docker files, you should try to do everything in non-interactive mode. I know that most Unix commands, you can pipe the thing so you can show that. Technically, if a command needs an input, maybe you could use, for example, a combination of environment variables and use pipes to be able to do that for you. But I wouldn't count on that, okay? So my recommendation is that everything should be done in a non-interactive way. And if you need if your application needs to consume a password through a database, for example, maybe it should be given as a runtime property, not when you're creating the container, because, well, I'm trying to think of use case, but most of the times you don't want to fix those parameters when you're building your container. You want to change these parameters when you run in your container. So maybe it's easier for you to use a combination of environment variables, and I'm going to show you, last topic of today, how to use this ConfigMaps and environment variables. Okay. Another question from Gabriel. Is it also possible to run an unregistered script before the containers get destroyed? Not that I'm aware to. Usually the container just gets killed or it dies by itself. So no, no way to unregister. But your container, your application, your process inside your container is going to receive a SIG signal when you're running on top of Kubernetes. So your application, depending on how you program that, you might have a chance, for example, to perform some cleanup resources before it gets killed. But if your application suddenly dies, I'm not aware of anything that you can do. I've read in Kubernetes, now you can use what we call init containers, which are containers that can that initialize your environment before your application containers run. For example, sometimes you need to create some complex IP tables rules or something like that. So you already have init containers. I don't know if you have like kill containers or finalizer containers available in Kubernetes, but that's a good question. I might need to do some research, but I know that you can do the init part. I don't know if you can do the termination part. Okay. Emmanuel is saying, is the video constantly buffering for everyone or is it just me? Emmanuel, I'm not sure. I'm looking here in my terminal in my analytics. Everything seems okay. YouTube says excellent collection. I hope it's on your side, but maybe doing a refresh could help you. If anybody has any issues with the stream, please ping to me. But Stream health seems here, everything 100%. Okay. So yeah, Bruce and Daniel say video is fine. So I hope that it was just a glitch in your side, manual. So let's move forward then. Thank you very much for the feedback. And let's move forward resources limits. So let's move here back to my terminal. And remember, I'll just be copy and paste the commands right now because I need to save some time. And kubectl get an s. Yes, I have. I'm probably working in my space. So kubectl get all. I have a lot of things. So let's try to delete everything so I have a clean. Delete all dash all. So yes, and today is much faster. Is expected to be much faster because all the demos today I'm running on top of Minikube. Okay, so I'm not running anything in the cloud today, so I don't have like complicated load balancer that takes forever. But as you can see, it's taking longer than expected. Get all. Yes, my pod is terminating, and I still have a service. It's gonna take some time, but I hope it won't impact anything that I'm doing right now. So what we can do today? Share, yes. So I'm following the tutorial. So let's try to use resources. I'm going to create a first deployment, which by the way is another Spring Boot application. So I create another deployment, which by the way, yes, deleted, completed. So I have created, if I get deploy, I have the my boot application. Okay, and let's try to do this. I'm going to get the name of the pod and kubectl describe. And you can see here that on the specification of my pod, I don't have anything saying memory constraints. So how can I specify memory constraints for my Kubernetes deployment? So what I'm going to do right now, I'm going to deploy the delete deployment that I just created. And I'm going to create another one which has the proper information. I'm going to create this particular deployment. Okay, and if you're wondering what does this one contains, let's do the same. Okay, you can see here that on this particular deployment, I was able to specify something here. So resources request 300 megabytes of memory and 10,000 millicores, which means equals to 10 cores. And maybe it's too much. So yes, I asked it to deploy and I requested 10 cores, which is a lot of CPUs. So if I just get pods, it's pending. And why is that? Because in my particular deployment, I'm requesting 10 CPUs and I don't have 10 CPUs available on my machine. I hope you do in your local machine, but in my machine, I don't have 10 CPUs available. So Kubernetes saying it's pending because, well, guess what? I can't run this particular pod anywhere in your Kubernetes cluster because you're asking too much. So you just realized that that particular request here, this request part is how Kubernetes know where to schedule your pods. So if I asked for 10 cores and I had one server in my cluster that had these 10 available cores, you can be sure that Kubernetes would be scheduling that particular pod for that particular node, for that particular machine. So, and the other ones that, well, they didn't have enough available cores, well, Kubernetes would just discard those nodes. I can't run your pod there, so Kubernetes is going to schedule your pod to be run in the other nodes that have enough capacity. Okay, so we learned about requests. What else can we do here? I can show you the events, for example. You can see that, yeah, you have a lot of events here for this particular, for what happened in my pod, but you can see that it's trying to scale, but it wasn't available. It wasn't failed scheduling here. It's a warning because, well, insufficient CPU. And let me remove my face here. Yeah, as you can see here, insufficient CPU. I can't schedule your pod because I don't have enough CPUs for you. Cool. Let's delete this deployment and let's try to run. Oh, not this one. I'm going to delete this deployment and we're going to run another deployment with more reasonable requests. So if we try to see what's inside here, and this particular one you can see here that I'm requesting only 250 millicores, which is a quarter of one core of my CPU. So my CPU might have like multiple cores. I think I have 6 cores here in my CPU. So it's only requested a quarter of the core, a quarter of a core. And here I have another section here. I have limits, and so my deployment is requesting 300 megabytes of memory, and it's limiting in 400 megabytes. And CPU, it's requesting 250, but the limit is 1 CPU. What's the difference between request and limits? So requests is the numbers that Kubernetes is going to choose to when deciding where to run your particular pod. So Kubernetes know how much memory and how much CPUs you have in each one of the nodes in your cluster. So the request is the number that Kubernetes uses to decide where is it going to run your pods. So it's only going to schedule your pods in the nodes that have enough available resources. Okay, so that's the request part. And the limits. Once your pod is already running on the nodes, it can consume up to the limit. Okay, so if your pod tries to consume more than 400 megabytes here, it's going to get killed by Kubernetes because it's not being a good Kubernetes citizen. And if it requests more than 1 CPU, well, it won't be able to because Kubernetes is going to throttle the process to up to 1 core. And it's going to be going to do some basic math around how many milliseconds per second it can consume from the CPU. Okay, so that's the difference between requests and limits, and that's a very common question. Well, request is when it's used by Kubernetes to decide where is it going to run your pod, and limits, it's the hard limits that Kubernetes is going to give to your process to be consuming from the node resources. Okay, and that's it. I created that and it's working, and if I did everything correctly, I should be able to see this pod working. Yes, it's running because I have enough memory and I also have enough CPUs to be running this particular pod. Okay, let's try to create a service too to see if this Java process is really working. Okay, and I need to change this a bit. Mission. Let's get the port and let's try to curl this. Yes, it's working properly. Okay, and these commands, remember, are just copying from the tutorial because or else it's going to take a lot of time. Okay, and let's see. Yes, it's saying that I have 1.8 megabytes and 3 cores available because that's the total amount that is being reported by my Java process. Okay. And what I can do right now, I can try to consume the entire memory. Yeah, well, my container died. So let's try to do it again. I'm going to be splitting my screen here horizontally. Watch kubectl get pods. Okay, so it's running. It restarted once and the age is 3 minutes. So what I'm going to do here, curl consume sys resources. Yes, it's seeing the entire memory available for it, and consume. What is? Oops. My container tried to consume the entire memory of the machine because it thought it had 1.8 gigs available, but the limit was 400 megabytes. So Kubernetes detected, oh, it's consuming too much memory. It killed that particular process and it already restarted. That's one of the benefits of using Kubernetes. The process died. Kubernetes said, oh, I need 1 instance running. My pod is already back and running. So if I just curl this guy again, yes, it's already running. Okay. And say here, I have a question. Are the Docker files you showed earlier in the GitHub repo? Yes. Everything is the GitHub repo, okay? So if you go to the apps folder, you should be able to see we have a lot of YAMLs and Docker files available for you. So everything that I'm doing here is available on the GitHub repo, and which, by the way, let me paste it again for you. Yes, if you go to this URL, dn.dev/kubetutorial, you see the files that I'm using right now. Okay, So yes, it worked and it died. Let's try to kill it again. Consume. You see, oops, empty reply because it got killed. Cool, isn't it? Yeah, it got killed and Kubernetes is restarting again. You see the restart equals to 2 because it detected and restarted my pod. And if I even want to know why it died, I could get the pod, the name of the pod. I couldn't find it. kubectl get pods. Oh, yeah, it died already. But if I took the last pod that died, I could see that, well, it died because, well, it was out of memory, right? So that's all for resource limits. I hope I made the distinction between resource, the requests, and limits clear in your YAML file. And let's go to the next step, which is rolling updates. And let's see if I have any here. So what is a rolling update that I can do? And the best way for me to show that is using a demo. So I have here, watch kubectl get pods. Yes, my pods are here. So let me try to curl the service here. So you can see that I have Aloha, it's working. And let's try to, let's see, I'm going to switch to another tab. So kubectl, I'm going to use this one. And if I go back here, what we can see, replicas, here. My deployment has one replica because that's all that I've specified. And you can see here that a strategy for performing the update of my particular deployment is this one, rolling update, max surge, max and available 25%, which is the default here. So no big changes. So if I just change the number of replicas here from 1 to 2, I just go back here, change to 2, and save the file. So let's go back here to my terminal. I save the file, and you can see that my deployment will be, did I save the file? Yes, save the file, yes. And I already have like 2 pods working. It was super fast. I've seen the errors here because it's a traditional Java application. Yes, connection refused. And I already have 2 pods working. Okay, so I have 2. I think and actually let's try to do different. I'm going to scale this one. I'm going to split here again. Another way for me to scale my deploy / my boot replicas equals to 3. So let's try to scale. So you can edit the deployment, or you can use the scale command to be able to scale the number of instances. So scale that to 3. You can see the arrows here on the top of the screen again. And now the 3 instances should be working. Okay. So what can we do right now? We can update the image to see the rolling upgrade working. So what we're going to do, again, I can edit the deployment, or I can use the command kubectl set image deploy my boot, and my boot is going to be key.io/rhdeveloper /my boot v2. So let's switch that, and I'm updating. And what is the rolling upgrade? And I had a question here before in the chat saying, well, how does it perform? Yes, with the rolling upgrades, is this way. I told Kubernetes that I want 3 instances running at this given moment in time. And you can see here that what happens, the problem is that it happens fast. But what happens if I set Kubernetes, I need 3 running instances at a given moment in time. When you perform a rolling upgrade, Kubernetes is going to instantiate 1. So you have 4. And when this one is ready, Kubernetes is going to kill one of the other ones. Okay, let's do this because it's easier with my fingers. So you have 3, and Kubernetes create a new one. So once this one is ready, Kubernetes is going to kill this one. And it's going to create a new one of the new version. When this one is ready, it's going to kill one of the other ones. And when we'll create a new version, and when all 3 are ready, Kubernetes will kill the old one. Okay, that's how a rolling upgrade update performs, because this way you always have the guarantee that if you ask it for 3 instances, you always have at least 3 instances running into production when performing any kind of update. in your deployment. Okay, that's how a rolling update works when using Kubernetes. Cool. And what else can we do? You can see we had these errors. Let's try to do it again. But now instead of using Spring Boot, I'm going to use Quarkus and set the image. You can see again here in the middle. You can see here the rolling update performing. It's creating new ones. It's terminating. So, and you can see that everything is already updated. Right now, you didn't see any errors because Quarkus usually Quarkus takes like this particular application, I think it takes 9 milliseconds to be able to boot. And most of the times you won't see any errors, but you might have such a coincidence that that exactly 9 milliseconds when that Quarkus application is starting, you could see an error. So how do we prevent these errors when performing rolling updates in Kubernetes? That's the next session. We're going to learn how to use Liveness and readiness probes. Okay. So, what else? So stop here. So what I'm going to do, delete, deploy my boot. Okay, delete the deployment, my pods are getting killed, and all should be good. So what can I do right now? I'm going to switch to the other time because I want a full screen. And let's try to create a deployment with the liveness and readiness probe sets. So I'm going to copy paste here. And don't worry, I can, for example, kubectl, edit deploy, and code. So what I did, I created a new deployment. And the interesting part that I've added to this particular deployment was this section, the liveness probe and the readiness probe. So how does it work, the liveness probe? In particular, what we're going to do here, we're using the HTTP GET. It's going to get the /8080. The scheme is HTTP. And again, the readiness probe is going to be /health. What's the difference between... Oh, I have a question here. I suppose it's in Greek or Cyrillic letters. Alexei? Yeah, I hope it's right. Yeah, sorry, I don't know how to read Cyrillic. Is it possible to run different services exposing the same port? Good. When you mean service, I think it's like an application, like multiple ports running on port 80. Yes, because very likely you'll be exposing those applications using different Kubernetes service for that. So you can create like multiple Kubernetes services, which will be resolved by name, and each one of those names can be mapping like to this particular application running on the same port. So yes, it works. And Bruce Link is asking, what are you using for multiple split screens? Well, split screens, I'm using iTerm2. I'm running this streaming on a Mac, and my terminal is iTerm2, so you have this feature of creating multiple split parts of the screen. Okay, it's very nice for when you're doing some presentations. And Peter is saying, Quarkus on a quarter of a core. That's quasi. Well, yes, you can trickle your tongue if you speak that very fast 3 times. So you can see here, back here, I created liveness probe and the readiness probe. Don't worry about the syntax. You won't be typing that by yourself. Just like myself, you'll probably be copy and pasting from all the YAML files because YAML is too hard to be edited by hand. You should be using a tool. And if you're using OpenShift, for example, OpenShift even provides a nice GUI for you to be creating those endpoints anyway. What's the difference between a liveness probe and a readiness probe? That's a very good question. For example, I don't know if how many of you ever used like Docker health checks. Well, Docker health checks like copied feature of Kubernetes. But to prevent the errors that we had when performing the rolling update, to have, well, the process is not ready to reply. So what can we do? The liveness probe in Kubernetes is to tell if your application is live. And if Kubernetes detects that your liveness probe failed, Kubernetes is going to restart your pod. Okay? So the liveness is if your problem can be solved by restarting your pod, restarting your container, then you should put the check on the liveness probe. So I'm running out of memory. Well, maybe it should be a liveness probe because restarting would fix that. Well, I don't know. I had some weird kind of error. Well, put that on your liveness probe if restarting your application will solve the problem. And the readiness probe. Well, the readiness probe is the probe that Kubernetes uses to detect if it should be sending production requests to your pod. So what happened in our previous example is that we didn't set the readiness probe. So whenever the liveness probe was up, Kubernetes was said, oh, this thing is ready. Send production requests, even though your Java process wasn't ready yet. So that's why we need the proper liveness probes to be able to prevent the error that we had in the past demo. So right now, with this liveness probe, we should be able to have like a very smooth rolling update of our application. What should we putting in the liveness probe besides the basic stuff here that we have? Well, that's a heated discussion, but some people advocate, for example, that database checks should be put in the liveness probe. For example, just do a select one from dual in your database to check if your database is working. And why is that? Well, if your application is down or if your application is super slow, restarting your application, actually, if your database is down, restarting your application won't solve the problem because the problem is not in your application. So if you leave the database check on the liveness probe, Kubernetes won't keep restarting your application. Okay, you just won't send production requests to your application because your database is down. And once your database check goes up, it means, oh, I'm ready to receive production requests. Kubernetes will send production requests to your application. Okay. Some people argue that it's not good because if you have a very complex microservices mesh, then you have like cascading failures, and I can understand. But for most of the application, for most of the simpler architectures, putting database checkers on the liveness probes is a good strategy. Okay. And let's move here. So let's stop here. So, oops, move to the terminal. So now that I created the proper liveness probes here, what I can need to do it again. So let's curl again. Do the same example. Yes, I have 3 instances running. I have Aloha, and let's try to edit that. So kubectl set image deploy / my boot. My boot is going to be key.io rh / developers / my boot and v2. And you can see that, yes, now it's going to be even more clear. Well, container is running. You can see 0/1 here. Yeah, because it's running, but it's not yet ready. So you don't see the request going to Bonjour. And now that it's ready, oh, now I can see some Bonjour going there. Okay, and I think my camera just froze. Don't worry. Yeah, oh gosh. I'm just going to remove my face here. You won't miss much. Because my camera just froze. I don't know why it happens, but it happens. Okay? Yeah, damn it. So, yes, I have Bonjour here, and now everything should be Bonjour because everything is live and ready. Cool? So you should always check your liveness and readiness probe so you can see you can have your very smooth rolling updates in Kubernetes. Okay, last part of this particular tutorial, and let's see my face again. You can see me frozen, or you can don't see my face. I think don't see me, it's a better option. So ConfigMaps, let's go back here to the browser. So ConfigMaps is how you provide properties to your particular application. So if you go to this Java code, the Java code is getting a lot of properties from environment variables. So let's try to change here. So I'm going back to my terminal. And I'm going to delete this deployment, deploy my boot. Okay, I'm going to create this new deployment. It's terminating, and this one has only one instance, I guess. Yes, it's already returning Aloha here from version 1. And what happens when I curl this particular endpoint? Let's curl in this other tab. Curl. Oh, I didn't set here. So IP and the port. And let's do the curl. Aloha. Yes, it's working. And configure. Yes, you can see that here's the configuration. I didn't provide any environment variables, so everything is going to return the default value. Okay, and how do I set the environment variable for my particular deployment? So we can do this with the setenv command. Setenv deploy my boot. I'm going to say greeting is going to be, oh, let's do it in the other terminal because here's more fun. Okay, kubectl setenv deploy / my boot. I'm going to say greeting is going to be, because I'm Brazilian, I'm going to say hola. And hola, oh, I'm performing the rolling upgrade. And you can see here in the top of my screen, yes, it's already returning hola. Cool, isn't it? I could be now, for example, saying hola instead of hola could be salut. And, well, it's Spring Boot, no liveness probes, yes, readiness probes, yes, yes, it's already updated. So you can give these environment variables for you. So I can set other variables here. I can also set a JDBC connection here. And every time I'm changing the environment variable, I'm creating a new release, which means I'm creating a new revision in my deployment history. kubectl rollout history deploy my boot. You can see here that I have multiple revisions. It's going to be in the history, which is a good practice because every time you change an environment variable, something might go wrong, and you always have the option to undo. You can always roll back your release. And if you curl this particular endpoint here, you can see that all of those properties that I typed on a setenv are available here. Greetings, salut, love, aloha, and the JDBC connection driver is already here. Okay? And if you try to describe this particular deployment, you'll be able to see that those environment variables are available here. Okay? And, oh, I don't want to be setting up these environment variables manually like you did here on these commands. Maybe can I use some automated way? Yes. The best way for you to be providing those things is through a property file. So if I go here, cat, let's switch folders, cat apps config some properties. Okay. So I created a properties file here, which contains this greeting, Jumbo, love, amour. So I can use this one. So if I want to reuse this properties file across like multiple different deployments, I can create a config map. And the way for me to create a config map is by doing this way: create cm my config from end file, and I point to a properties file. Once I do that, you can see that it was created. If I ask to print as JSON, you can see that I have here the data, greeting, Jumbo, and love, amour. And how do I make my, for example, my particular deployment to use it? Well, let's use this other one. Apply. You can see here that I'm creating a container, it's running the other terminating, which means I updated that. And if I curl this other endpoint, you can see, yes, the properties are here. Or no, is it running already? Terminating, yes, it's running. Yes, I think it's right? Yeah, kubectl get cm my config. Yeah, Jumbo and amour. Okay. And why it didn't work? Interesting. You should be using. Let's see if I did something wrong. kubectl at deploy my boot. So I should, if I did everything correctly, oh, right, it's using here. So I didn't use the properties, I created the specification here. So what I use, I created the wrong deployment. Let's see if I find the proper YAML file here. And you can see my face right now because I'm trying to find the right file. So let's go back here to the terminal, and I hope this is the one. So, oh yeah, this I applied the wrong file. So you can see here that if I want to specify from a config map, I just have to type this and from config map ref name my config. So I applied the wrong file. So yes, kubectl apply dash f dash f. Okay, now it should be good. It should be restarting. kubectl delete deploy my boot. Okay, terminating. Do it. You always start from scratch if you want to make sure everything is working. And let's see the curl, it's still failing. Yes, Jumbo, yes, it took from my config map and it's working. Okay, and now, well, my face is frozen over there. Well, thank you very much for coming. I'll leave my face frozen here, but thank you very much for coming to this particular session. I hope you enjoyed that, and I'm already 10 minutes over time, but I hope you enjoyed the content. And remember, everything that we did is available online and open source. If you want to have any suggestions, comments, please create a GitHub repo issue or send up a request. We're always happy. And I'm saying here, let's check the chat. The chat here. Gary, well, thank you very much for joining us. And Chris, tweet out a picture. Yes, I'll tweet a picture. Maybe with my frozen face here, it would be nice. I have a lot of gears here for the setup. Yes, I'll be tweeting. Just follow my tweet. I'll be posting in the next minutes. So, yes, and that's the final message. You can see my weird face on the screen on the chat. Thank you very much for coming, and don't forget to register for the upcoming DevNation Master courses available on dn.dev/master. Okay, well, that's all for today. Thank you very much, and as always, please take care and stay safe, and I hope you to see next time, maybe next week. Bye. Have a great week.